Right, good morning class. So you guys had some homework on page 230. It was exercise 7.3. So we're done with 7.2, no? Right. We went into a reduction formula. We spoke about... So 7.3 you had to do what? We done 7.3. So what was your homework? No homework. So why when you left here you didn't like go in a panic and say, we don't have homework? Oh, so you didn't go through the homework. Oh, you wrote an exam, I remember now. Right. So what is there any homework that I must mark? Yes, which is? Okay, I'll ask the question again. We stopped at exercise 7.3. Did I give you homework on 7.3? Yes. That was for the lesson before most. Yes. But now it must be marked. Yes. Was there any problems with exercise 7.3? No problems at all. Okay. Anybody else have a problem? So now we're going to look at further reduction formula, the function values of 90 plus and minus theta. So this is K and L is fine, eh? No issues there. Okay. So looking at this here, further reduction formulae, the function values of 90 plus or minus theta. It says use your calculator to determine the values of the trigonometric functions given in the following table. So what I want you guys to do is to draw this table. Okay. And then you punch it in your calculator and work it out for me quickly. Okay? I'm going to pause the video at this point. Okay, so when we punch this in the calculator, we said sine of 30, you got half. Okay? Then when you went sine of 60, you got half. What's up? Sine of 5? 0.09. Sine of 20? Sine of cos of 80? Cos of 72? When you see cos of 85, you got 0.09. Cos of 70, you got 0.34. Sine of 10, you got 0.17. Sine of 18, you get 0.31. Not so. So what do you notice? In the line 1 is the same, the row 1 is the same. Row 2, sine of 5 is the same as cos of 85. Row 3, you got sine of 20 and cos of 70. Cos of 80 and sine of 10. Row 5, cos of 72 and 80. What do you notice other than they're the same? What's the relationship that is existing between the functions? Yes? Get 90. You all see that? 30 plus 60 is 90 in row 1. 2 plus 5 is 85 in row 2. 20 plus 70 is 90 in row 3. 80 plus 10 and 72 plus 80. So they add up to 90. What else do you notice? We got here sine, cos. Sine, cos. Sine, cos. Cos, sine. Cos again now. And we got sine. So that means to say that in general terms, if we have sine of an angle, okay, would be the same as cos of its complement of that angle. Okay, so in other words, sine of 90 minus theta is equal to cos of theta. So let's put this into play here. Remember here we had cos of 72. Cos of 72 is the same as sine of 90 minus 72. And what's 90 minus 72? 18. Can you see sine of 18? It's the same as cos of 72. Does that make sense? What would the other one be? We're going to end up with sine of theta. It's going to be the same as cos 90 minus theta. We can check. We ended up with sine 30. Sine 30 is the same as cos 90 minus 30. What's 90 minus 30? Cos 60. So cos 60 is the same as? Will you guys understand? So importantly, we have now your reduction. These two gets added now. That if you have sine 90 minus theta is equal to cos theta, and cos, just throw it here rather. Take this to the cos diagonal. So you got here again all stations to claim on. That's your 90 minus 90 plus. That's all. So what is sine 90 minus theta? What is cos 90 minus theta? So what is sine 90 minus theta? We said it earlier on. It's going to be cos of theta. And cos of 90 minus theta is sine theta. You're going to the quadrant 2. You say 90 plus theta cos 90 plus theta. So 90 plus theta takes you in the second quadrant. Is sine positive or negative in the second quadrant? Positive. So but it changes to cos of theta. Although it changes to cos, it's going to be positive. Okay, because the original state is sine, which is positive. If we look at the next one, cos of 90 plus theta, which quadrant is that in? Quadrant 2. Is cos positive or negative in the second quadrant? It's negative. Although it's changing to sine, it's going to be negative sine. Can you see that, people? Now 270 has the same effect. Okay, you can do the trigger ratios without 270, but it just makes it so much easier if you have 270. So you say sine of 270 plus theta and cos 270 plus theta. You fill in those answers there. Then you got sine 270 minus theta and cos 270 minus theta. Fill in those four. So what would sine of 270 minus theta be? What would this one be? Negative cos theta. 270 minus cos of 270 minus theta? Negative sine theta. Okay. (270 plus theta) is negative cos theta, and cos of 270 plus theta positive sine. Who's confused? You all understand? It's fairly simple. People, what do we call 90 degrees? If 180 supplement to what is 90? Complement. Not so? Complement. And we call this, when we're busy with 90 and 270, we call this co-ratios. Complementary ratios, or co-ratios. Okay. So the co-ratios is sine 90 minus theta becomes cos of theta, and cos 90 minus theta becomes sine. Of course, if we're going to go into 90 plus, the sign is going to change itself. Right, you guys understand? Right, let's look at the example dealing with this. If you want to read more on this, is on page 231, the theoretical approach to proving this here. We don't have much time now to go through it. Okay, there we go. We want to go through the proofs. When we did reduction formula, the initial introduction to it, we spoke about the diagrams. You remember? Now if you want to go with that x and y's, that's on page 231 again, dealing with that co-ratios. Okay. So let's look at the examples on page 231. So the only time the ratio changes is when you're busy with 90 and 270. That's the only time the ratio changes. Okay. You're busy with 90 and 270. You will see 270 very, very, very little. Okay. But 90 will often be used. I don't even think this textbook uses 270. There's examples on page 231. Okay. And also with the new CAPS document syllabus, they took it out. Okay. But you'll see later on when we do work from different textbooks, you'll see 270 coming. Okay. So I don't want to just omit it. Just use it as is. Alright, so in example 1, the question says, write the following as a ratio of theta. I'm sure you guys can do this. Right, do this quickly. Yeah, I must give you a test on this, no? I just thought about it now. Just you would like to know when already. When would you like the test on this? Friday. Jesus. It's like forever and a day. Right, you guys finish? Guys finish? Who's still busy? Okay. Yeah. Right, so let's do this. You'll always see when I do these sums, I always draw the cost diagram to remind me of the signs with regards to the ratio, with the function. So sine of 90 minus theta. Answer is? So that's 90 minus. So it's going to become, is sine positive or negative? Positive, but becomes positive. Look at the next one. 360 minus alpha, which quadrant is that in? Quadrant 4. So in quadrant 4 is tan positive or negative? Negative. Becomes tan of alpha. Not so? The next one, cos of 90 plus beta, which quadrant is that in? This was actually 90 minus, no? It was that one. 448. But for C, 90 plus, quadrant 2, is cos positive or negative? Negative. What changes to? Sine. Any confusion there? Not yet. Example 2, I think this is page 132. No? Don't copy the answers from the book. No? Well, now you say yes. Right, write the first one down. Do it. Guys done with the first one? When does sine change to cos and cos change to sine? 90 plus or minus, we could say. That's the only time it changes, no? There's no function. Alright. So here we go, all stations to Claremont. That is 90, 180. Cos of 90 minus theta, which quadrant is that in? The first quadrant. Is cos positive or negative? Positive. What changes to? Sine. Over. 180 plus, which quadrant is that in? Third quadrant. Sine positive or negative? Negative. Sine. Or must I change that to cos theta? No. When does it change? 90 and 270. That's the only time it changes. So that cancels. Leave you with? Okay. Try the next one. Sorry? You guys finish? We're still busy? Give me another 30 seconds. Alright. So let's look at B. 90 plus theta, which quadrant is that in? Second quadrant. Is sign positive or negative? Positive. Stay or remain, change? Remain the same or change? Change. When does it change? When does it change? 90 and 270. 360 minus, which quadrant is that in? Fourth quadrant. Is tan positive or negative?
Negative.
Oh, not positive, you say. Okay, negative tan alpha. So what's positive times a negative? This? Negative. Oops. Negative tan alpha, no? So it's going to be negative. So what can be done now? Tan can be written as? So cos the alpha over 1 times sine alpha over cos alpha. Now what? Cos cancel cos alpha. So it's negative. Okay, any confusion there? No? I would like you guys to write this note now. When dealing with the reduction formula, focus on the following questions. In which quadrant does the angle lie? Second, what is the sign of this ratio in this quadrant? In this quadrant? The third one, does the ratio change or remain the same? Those are the questions you should be asking yourselves when dealing with the reduction formula. Okay. Okay? Guys ready? Done? Now the bell's gonna ring soon, so I just need to do these two examples. The next two still. Okay. So there's the next two. Again, the question is to simplify. In C, you are given sine squared 90 minus alpha, or x, plus sine squared 360 minus x. Do that one quickly. That's worse, no? Alright. So let's look at this one. Again, all stations to Kleeman diagram. That is 180, this is 90. 360. 90 minus, which quadrant is that in? It's in your first quadrant. Sign positive or negative? Positive. Does it change? Yes. Why? Because I was with 90. So it becomes cos squared x plus 360 minus, which quadrant is that in? Fourth quadrant. Is sign positive or negative? Negative. But because of the square, remains positive. Not so?
Yes, sir.
Did I explain that already?
Yes, sir.
Yes. So it will remain positive, sine squared x. Now, must it change to cos squared x?
No.
Why not?
It's
It's not 90. You guys understand?
Yes, sir.
So what is sine squared x plus cos squared x? Or cos squared x plus sine squared x? The answer is? Any confusion there? Alright, let's look at D. D, you got cos squared 180 minus beta over sine 90 minus beta times tan 180 plus beta. Write that down and you do the first step. Right, you guys finish?
No.
You're struggling? No, okay. Okay. So we're on the examples on page 232. There's so much making a little much noise. Okay, so 180 minus beta is in which quadrant? 180 minus beta. Second quadrant. It's positive or negative? The second quadrant is negative. But because of the square it remains positive. So it's cos squared beta over 90 minus, that takes you to quadrant 1. Sign positive or negative in quadrant 1? Positive. Does it change?
Yes.
Why? 90. So it's cos beta. Times 180 plus, which quadrant is that in? Third quadrant. Is that positive or negative? Positive. Tan beta. So what do we do now? Tan can be changed to sine. So that's going to, and this cos cancel one of those causes. Not so? That's going to become cos beta over 1 times sine beta over. What can happen now? Cancel cos. So I'm left with sine. Alright, do you guys understand? For homework and for the last couple of minutes left of this lesson is going to be exercise 9.4, 7.4. Chapter 9 is geometry. Yeah, you see the geometry still in me. Right. Exercise 9, 7.4, page 233. You do for me, listen. You do for me, out of 7.4, you do for me number 1, the first column. Number 2, you do for me A, C, E, G. So you're doing every alternate sum. Okay, starting with A. Number 3, the same thing, A, C, and E. You don't do number 4. However, you do number 5. Okay. Or you guys can do the whole thing. I just realized now you got a long weekend. Am I right? Yeah. Yes. Okay. So since you're lying to me, I think I must give you a little more work. So you only want her to do well.
I'm the only one who said no. You don't.
You see now. Listen, you said it so loud that we only heard you. Now listen. Whenever I mark your paper now, I'm going to remember. Oh, you that girl that don't like. Yeah. I was just get to know your name. What's your name? I thought you weren't going to give your name. Okay. Right, 7.4, you're going to do the whole exercise. People, enjoy the long weekend. And Eid Mubarak. To those of you celebrating Eid. Now you do the whole exercise. Everything. Good afternoon.